In this video, we will be answering this pulley question, where we have a 100-kilogram block and we are told that it takes 6 seconds for it to reach the floor after being released. And we want to know what is the mass of the block on the left. Now, the first thing I always like to do is draw my free body diagrams. I will need to draw 2 free body diagrams to represent our 2 blocks. Starting with the block on the left, we know the force of gravity will push down on it, and the tension force from the rope will pull up on it. Now looking at the 100-kilogram block, we know the force of gravity will push down on it, and the tension force will pull back up on it. And the most important thing that you have to recognize is that these 2 tension forces are the same. So the tension in the rope connected to the block on the left is the same magnitude as the tension for the 100-kilogram block. And now that I've drawn my free body diagrams, the next step is our Fnet equations. And again, we will need 2, one for the block on the left and the other for the 100-kilogram block. Starting with the block on the left, we can see that Fnet is equal to the tension force minus the force of gravity. And now let's think about what's happening here. We are told that the 100-kilogram block is released and it falls to the floor. That means the block on the left is going to accelerate up, while the 100-kilogram block is accelerating down. And remember, because these blocks are connected to a rope and moving together, their accelerations will have the same magnitude, but they will have opposite directions. Now that we understand that these blocks are accelerating, we know we can replace Fnet with ma, and of course we can replace the force of gravity with mg. Now let's make our Fnet equation for the 100-kilogram block. Here we have that the net force is equal to the tension force minus the force of gravity. And because this block is accelerating, we can replace Fnet with ma, and we can replace the force of gravity with mg. Now the next thing I'll do is rearrange this equation for the tension force. And the reason I do that is because the tension force is the same for both blocks. So I can take the value of the tension force for the 100-kilogram block and plug it in to the tension force for the block on the left. And when I make that substitution, we get this equation. And now remember, we are solving for the mass of the block on the left. That means I need to rearrange this equation and isolate for the mass of the block on the left. And once I've isolated for the mass of the block on the left, I get this equation. And notice the only variables we need are the accelerations of the blocks. So how do we solve for these accelerations? Well, we need to use kinematics. And the reason I know that is because we were given the 100-kilogram block's change in position and the time it took to change position. We also know the initial velocity of the 100-kilogram block. It wasn't moving, so it's just 0 meters per second. And based on what we know, we can use this kinematic equation to solve for the acceleration of the 100-kilogram block. All we have to do is plug in our values for the block's final position, which was 0 meters because it hit the ground, its initial position, which we were told was 1 meter above the ground, its initial velocity, and delta t. And then you just need to rearrange and isolate for the acceleration. And what we find is that the 100-kilogram block accelerated at a rate of negative 0.056 meters per second squared. And it makes sense that the acceleration is negative because the block was accelerating down. And now that's the acceleration of the 100-kilogram block, but what's the acceleration of the block on the left? Well, remember, because the blocks are connected by a rope and moving together, the acceleration of the block on the left is equal to negative the acceleration of the 100-kilogram block. So I can easily solve for the acceleration of the block on the left, and we find that it's equal to positive 0.056 meters per second squared, which makes sense because it's accelerating up. And now I have everything I need to solve for the mass of the block on the left. All I need to do is plug in my values, and what we find is the mass of the block on the left is about 98.9 kilograms. And that's the answer to this question.